Hello, Monarchs. Welcome to the first video for lesson 6.4. Today we're going to be talking about special types of systems. So we've been solving systems all unit. That's what this whole unit was about, right? It started with solving systems by graphing. That's where we graphed the two lines found in the intersection. Then we did graphing by solving by substitution. Then we did solving by linear combination. Okay, so today we're doing special types of systems. So those special types of systems are going to be our parallel lines, our intersecting lines, or our just straight line, okay? So we have three different options here, right? When we have one solution, which is normally the case, we normally have one solution, okay? When we have one solution will have intersecting lines, and our solution will be where those lines intersect. So we already knew that, right? So that will be our final answer will be x equals a number or y equals a number. Okay. So that means your slope. So that means your slopes, you will have different slopes in your lines. Okay. So you'll have different slopes and you'll have different y-intercepts in your two lines. Okay. So your slopes will be different in your two lines and your y-intercepts will be different in your two lines. Okay. When there is no solution, that means the lines don't intersect at all, right? So that means we will have 0 equals a number and it won't be 0, right? So it won't be true. We'll have like 0 equals 5, which doesn't make sense because 5 isn't the same thing as 0. That's when we know we have parallel lines. These slopes on our parallel lines are the same. So we have the same slopes of our two lines, but our y-intercepts are different. Okay. Our last option that we have in our special types of solutions is when we have infinitely many solutions. And that means that we have the same exact line. The two lines lie on each other. So we will get 0 equals 0, or we will get a number equals a number. So we could get like 3 on both sides of the equal sign. And since 3 equals 3, that makes sense, right? Then that would be the correct answer. We'd have infinitely many solutions. So for infinitely many solutions, the slopes of our line are the same and the y-intercepts of our line are the same. It's the same exact line, right? So now our examples that we will follow here, we will use linear combinations to try and solve these systems here, okay? So for example 1, we're going to use combination. So first we want to make sure we have opposites when we add together. And if you look, we already do have opposites, right? We have a positive 3y and a negative 3y. Those are opposites. So we're just going to add these together right away, okay? So this is 1x plus 1x, right? There's a little 1 in front of both those x's. So that is 2x, okay? And then I have positive 3y minus 3y. That is 0. Those cancel out, right? And I get equals negative 8 plus 10 would be a positive 2. Okay, so I'd want to get my x by itself. I know that 2 is multiplying my x. So I need to do the opposite, which would be division. So I divide by 2 on both sides. So those cancels out. I'm left with x or 1x. X equals 2 divided by 2 is 1. Okay, so my x is 1. So if I look up here, you'll see that when I have x equals a number, okay, that means I have one solution and I have intersecting lines. So I know I'm only going to have one solution here, okay? So I have x equals 1. I need to plug that back in to solve for my y. So now I'm going to solve for my y. I'll use my first equation here. So I have 1x plus 3y, so x plus 3y, but instead of x, I'm going to plug in a 1. So I have 1 plus 3y equals negative 8. Okay, so 1 plus 3y equals negative 8. I'd subtract this 1 because I want to move that first. So I subtract 1 from both sides. Those cancel out. I get 3y equals negative 9. Okay, and now I know that 3 is multiplying my y because it's right next to it. So I need to do the opposite, which is division. Those cancel out. So I get 1y or y equals negative 9 divided by 3 is negative 3. Okay. So my ordered pair then would be 1 comma negative 3. So this is just a normal one like we've been completing. That just means that this is the point where these two lines intersect at 1, negative 3. So that's the one solution they have. Okay. So now let's move on to example 2. So example 2, when we look at it, you will see we can add right together because we already have opposites, right? So we have negative 2x plus 2x, that is 0, right? 0x. Then we have positive y minus y, that is also 0y, so plus 0y equals negative 6 plus 10 would give me a positive 4, okay? And I will go ahead and finish this on our next video, so please stay tuned for video 2 for lesson 6.4.